Okay, so this is lesson 5.6, and we're talking about direct variation. Direct variation sometimes causes some kids some problems. So please listen carefully, look over the examples, do the problems, and it's not very tough, but sometimes just maybe the wording is what catches kids off guard. It says direct variation. Two quantities, x and y, show direct variation when y equals kx. So we still see the y and the x there, but now we've introduced this k. And k, it says, is a number, and it can't be 0. The number k is called the constant of proportionality. It's also the slope of the line. The graph of y equals kx is a line with a slope of k that passes through the origin. So, two quantities that show direct variation are in a proportional relationship because remember, if they're proportional, they'll go through the origin. And now we just said, if they show direct variation, they go through the origin. So when we say they're in direct variation, we could also be saying they're proportional. So we'll be using those two ways of saying basically the same thing. So let's look at some examples and see what the heck they're talking about here. So in example 1, identifying direct variation. It says tell whether x and y show direct variation. Explain your reasoning. So what they did is they took the study tip says, other ways to say that x and y show direct variation are y varies directly with x and x and y are directly proportional. Okay, so what they did is they took the two green tables there, A and B, and they plotted the points just to show the graph. So when they plotted the points for A, you can see that that line does not pass through the origin. So we would say that they're not proportional, but for this section, we're going to say they do not show direct variation because they don't go through 0, 0. We could tell that just by looking at the graph because the second point there, 2, 0, it says it goes through y at 0 when x is 2. And we need it to go through when y and x are both 0. Now look at example 1b. There's a table there. They took those points, they graphed them, and that line does go through the origin. Because that line is a straight line and it goes through the origin, then we know it's proportional. But for this section, we say it shows direct variation. And it shows direct variation because it's a straight line that goes through the origin. Also, we could tell just by looking at that graph, at the table, that that line was going to go through 0, 0 because 0, 0 is one of the points that is right on the table for us. In example 2 here, identifying direct variation, it says tell whether x and y show direct variation. Explain your reasoning. They don't want us to graph these. They didn't give us a table. They want us to take those equations and try to put them in the form y equals kx. All the way from like the first slide here where it was showing y equals kx is how we show direct variation. So we take the first equation for example 2a, y plus 1 equals 2x, and we solve for y. That means we get y by itself. We would do that by subtracting 1 from each side, which would leave us with y equals 2x minus 1. Now, y equals 2x minus 1 is not in the form of y equals kx, because it's got that whole minus 1 thing going on at the end. If it didn't have that, we'd be good, but it does, so we're not. X and y do not show direct variation because of that minus 1 hanging on at the end, so no. For example 2b, 1/2 y equals x. Remember, we would multiply both sides by 2 over 1, which is just 2, to get rid of that 1/2 in front of the y. That would leave us with y equals 2x. Well, that does fall into the form y equals kx. In fact, if they asked us what k equals, we would say 2 because it's right in the place of where k goes. But it says y equals 2x. It does fall into the form y equals kx, so x and y do show direct variation for this one. So here are 6 problems to do on your own. The first 3, you're supposed to show whether x and y show direct variation by graphing them. Now you could also, remember since direct variation and proportional mean the same thing, you could just tell whether these are proportional, maybe by doing cross products throughout the whole table. But they want you to graph them, so you should take this opportunity to graph 1, 2, and 3. If the graph is a straight line and goes through the origin, bing, it shows direct proportionality, or they show direct variation. For 4, 5, and 6, you're supposed to put those equations in y equals and then see what you get on the other end. You're hoping for a y equals kx form. If you don't get a y equals kx form, then no direct variation. So give these a try. Example 3 here is a real-life application, and it says the table shows the area, that's y, in square feet, that a robotic vacuum cleans in X minutes. So the first thing they did is they took that table and they graphed it. That's the green graph on the right. So the y, that's up and down, that's area in square feet, and the x, that's the time in minutes along the bottom there. The graph the data and draw a line through the points. They did that. The graph is a straight line that goes through the origin. So yes, x and y are directly proportional. Okay? Write an equation that represents the line. So now we remember that the equation is going to be y equals kx. And k is the slope. So it says choose any 2 points to find the slope of the line. They chose the 16 over 1 because remember we put y over x. So they took 16 over 1. Now you could have done 8 over 1 half or 24 over 3 halves or 32 over 2. But why not put 16 over 1? It's already simplified for you. So the slope of the line is 16 over 1. And that's what you put in for the k, or constant of proportionality, all the way back from the beginning here, y equals kx. So the equation of the line is y equals 16 over 1, or just 16, x. Y equals 16x. Well, now we can use that equation. It says use the equation to find the area cleaned in 10 minutes. Well, 10 minutes, that's the x, so we can put that in for x. That makes this equation y equals, instead of 16 times x, y equals 16 times 10. And we know that 16 times 10 is 160. So when x is 10, y equals 160. So the vacuum cleans 160 square feet in 10 minutes. So on this on your own problem, it says, what if the battery weakens and the robot begins cleaning less and less area each minute? Do x and y show direct variation now? Explain. So now pause this and think about it. Now I've been thinking, after going through the lesson, but before you start on the practice problems, now might be a good time to stop this and go watch the journal page. Because on the journal page, you can see me working out problems, problem by problem. Then it might be best for you to go back and finish the rest of this lesson. So why don't you pause this right now and go and watch the journal page. You don't have to do that. It was just an idea. When you're solving these, on number 10, you'll add x to both sides. On number 11, you'll multiply both sides by 5 over 2. On number 12, to get y by itself, you subtract 3 from both sides. On number 13, to get y by itself, you add 5 to both sides. On number 14, first you add y to both sides. Well, actually, that's all you do on that one. On number 15, you multiply both sides by y. You'll get x equals 2y, and then you divide both sides by 2. On number 6, or multiply both sides by 1/2. Then on number 16, you divide both sides by x, and on number 17, you would actually, it's already y equals, and it just doesn't fall into the pattern.